So here we are at the final day of our greeting card app project. I don't think we're going to do any work today. I've just made this video to show you some of the additional figures that are in the master copy of the source code. And you're going to have that and you can play with them. These are mostly figures that I didn't think were really interesting or simply because we had limited time we couldn't go over. So I tried to go through the ones I thought you would enjoy. And then also today, I thought we might talk about other stuff that we can do with the app. So in case you really got into this, you want to play with it and extend it, I've got some ideas on how to do that. So it's really been a pleasure to work with you all this week. You know, I'm very passionate about this technology, and very few things please me as much as being able to share it. I feel truly blessed that I'm a professor and get to share my enthusiasm for things with people and improve their lives. So, okay, so we're going to look at these additional figures, and then again, I'll talk about some future directions. So this is the quad curve. Basically, I have the quad and the Bezier curve, and they're just super simple. So they just randomize some points and then use the functions that are provided by the canvas to do that. So, I mean, they don't really turn out very interesting. So this is the output for the quad curve. Um, Basically, again, we just completely randomize all of the values that go into the curve. Now, we might be able to make something more interesting if we kind of tweak the way that the parameters are generated so they aren't quite totally chaotically random. And that's one thing that you might want to do if you wanted to play with it. I did show you how I used the quad curve, for instance, in the cobweb and a couple other types of figures in a more controlled way. So the code for the quad curve is very simple. We make a big thick line by doubling whatever the width was that we already had. We move to a random xy point and we draw a quadratic curve to a random x1, y1 point using a random control point. And of course, the stroke actually renders the curve. So there's no function for this. This is inline code in our case in our drawing method. The Bezier curve is really not much different except that it has two control points, and you can kind of see the difference there. You tend to get a more rounded shape here rather than a kind of pointy one, although there are exceptions. Again, all the values are just completely random. And this is very similar to the previous code, except that I've got an extra set of points here for the second control point. And I don't think there are any constraints at all in the code here. I do think x1 and y1 are generated in relation to x and y, but other than that, everything is pretty much totally random in terms of the width and height of the canvas or the width and height that the user sets on the interface. So again, you could play around with this, and we did use the Bezier curve in some of the figures that we drew here. I'm trying to think, but offhand I'm drawing a blank. This one I kind of like actually, and it certainly could be spruced up and we could do more with it. I call this aster, which if memory serves is a Latin word for star. And of course an asterisk is a figure that looks like this. And basically this is similar to our regular polygon function that we went into detail with. And we use the same mathematics to calculate the vertex points. But now, instead of joining them with the sides of the figure, we simply draw a line from the center of the figure to the points. So, you know, we pass the context in. We do have a function for this one. We could probably inline this too. So we pass our drawing context in, the center point, the radius, how many sides we're going to have, and that actually turns out to be how many spokes. We have a begin path, Calculate our angle. Again, math.pi times 2 is a circle divided by the number of sides is how many degrees, or actually it's radians here that we have in each angle. And then we move to the center point of the figure, and we move our drawing context to that point. And then we draw the first line, which goes out. Now notice how this works. So this is x is radius, and y is 0. So that means that this is on the central axis of the translated coordinate system. And basically the way that the canvas does this is that's going to go out to the right. So that's due east of the center. And then the rest of them will rotate around from there. And that's what this does. So it just goes ahead and calculates the x and the y with the cosine and sine function, as we've seen, as we go out. I've always liked this figure. I used to generate these by hand when I was a younger person. And this is called a crystal. I used to call it a vertex cloud as well. And what happens here is we just generate a whole bunch of random points in a vaguely rectangular area, and then we draw lines from each point to every other point. So again, I used to call this a vertex cloud. It sort of looks like a crystal. It's pretty simple. Again, I do have a crystal method here, so we have to look at that function that we wrote for that. That's kind of funny, really, because crystal method is like sort of rock band. Anyway, we set our line width. These work better with a thinner. And then the number of sides here is actually the number of vertices or points. So we call the crystal function we're going to look at in a second. We pass the graphic context to it. The center point, the height and the width, which form that rough rectangular area I talked about, and then the number of points actually that we're going to generate in there. And then we draw everything. And so here's the first part of the crystal code. And so what it does is it takes the number of sides, it creates an array or set, which is empty initially of points, and then it runs through, and again, I told you that was the number of vertices, not actually the sides. There are no sides on this, really. And we go ahead and calculate an x and a y, and then we add them or push them onto the set. This is the JavaScript notation for creating an object on the fly. So this square bracket, curly brace unit here is an object, and the object has two properties, x and y, and then the actual value is the calculated vert x and vert y. So essentially this is an unnamed object that represents a point, and when we push that on, we add that to the point set. So this is not just a set of individual numbers, it's a set of these pairs of coordinates. Okay? And actually, I'm surprised I still have that in there. That's a debugging code that displays that value. I didn't catch that, so it ended up in the slide. It's still in the source code. It's been commented out, so it's not active. That's what this slashes are, comments. So what this first for loop does is it just goes through and it generates all the points that are going to be in the set. And then the second part, which is the final part of the function, it takes the set of points and rolls through them, and it connects every point to every remaining point. So this is kind of cool because it doesn't draw twice. So the first point, point 0, gets connected to every other point in the set. Let's see, why is that point -1? Huh. Less than points length -1. I don't really remember right now. Oh, I remember now. So it's kind of cool how this works. This would cause an error if it actually ran to the last point. So it's the last point -1. The reason for that is in the loop, it draws from this point to the next point. So here's how it works. For this variable P2, point 2, equals P plus 1, and then while P2 is less than the length. So again, this is the length minus 1, but this inner loop is going to go through all the points. So essentially, P is the first point. P2 starts at the next point and goes through all of the rest. So the first time through, it's take the first point and draw a line that connects it to every other point. The second time through, it's start with the second point and draw a line to every other point starting at the third. So you see, you never end up drawing twice, because by the time I get to the last point, I've already drawn every other point to it, so I don't need to draw at all. And that's why it doesn't go that far. It only goes to the second last point here in the outer loop. Kind of tricky stuff, but it's pretty neat. The other thing that's a little odd here is the way that the subscripting works. So as I mentioned on the previous slide, when we create the points, we give them an X and a Y component. And this dot X and dot Y disambiguates that. That's how we refer to that. So here, if you look at 0 as the first point, points 0 is the first set of X and Y in the point set. So this says read the X of the current p-value and the Y of the current p-value, and now draw a line to the next p-value. So P2 is always 1 greater than P. Kind of cool stuff. I like this stuff. The crystals don't always turn out nice. Sometimes they're too dense, and so the lines all just kind of blur together into a big blob in the center. So it's kind of tricky getting the right number of points and the right size. One thing we can do to improve this is we could look at how large the area is and set the number of points, the total number of vertices, to some relation to that. So then basically the larger the figure was, the denser the vertices would be, and that would probably look better. So that'd be something you could do if you wanted. The next one is pie. This is kind of funny, so you can see it's slices of pie. And I kind of dedicated this to Homer Simpson and Pac-Man. I don't know if you all are old enough to know who Pac-Man is. So I might be showing my age here. That's an early video game. Pac-Man was a little yellow face that consisted of a pie shape, and he would basically, the pie would open and close like he was chewing. And so you would go around and try to eat these power pills that you got points, and then there were these ghosts that would chase Pac-Man, and you had to run from the ghost. And every so often, Pac-Man would hit a special power pill, which would allow him to eat ghosts. And there was a sequel which had a Pac-Woman in it. And she was the same as Pac-Man, except she had a little bow in her hair. So it's kind of funny. Anyway, this is just a random arc that creates a portion of a circle. And we take advantage of the way that the Canvas drawing routines work. So they're designed really to work with paths, where you notice a lot of times you have a method that it starts at what's called a context point, the current point, and then draws like a Bezier curve or a quadratic curve to another point. And so what we do here is we use the begin path and the close path. When you use close path, it joins the very last point that you drew to the very first point that you started when you began the path. So what this does is it creates an arc with a center point of xy and a given radius that's passed into the method. Whoops, I'm sorry, that's not true. It's actually generated in the draw method. And then the start and the end are randomized. And again, you can recognize this pattern. We take 2 times math pi to get a complete circle. Math.random is going to return a value from 0 to just less than 1, or like 0.99. So this is going to be 0 to some almost complete portion of a circle. And then we do the same thing for the end, but we add whatever we get to the start. And here, actually, this would change stuff. If I turned this to true, it would draw the other way around. So because I don't have a complete arc, that'll make a different type of pie if I use true there. So one thing we could do to change the code here is we could just add a random code that would alternate it between true and false. I don't know how big a difference that would make in the figures that we get. Okay, that's everything that I've included for you. Let's just talk about some things we might do with our app in the future. I'm hoping to plant a seed here for you. And I'm kind of joking about this, but then at the same time, if you know, you end up taking this and making something that generates a bunch of cash, hey, don't forget me. I'd like a small share. That'd be kind of a nice thing to do and a fair thing to do. So here we have some ideas of more figures. So for instance, the asters, which basically are based on polygons, instead of using the same radius for each spoke, we can use variable ones. So I've actually done this in some of my other graphics programs. And you get something that looks more like a sort of twinkling star rather than an asterisk. We could also draw figures on the end points of the asters. So you could draw small circles, polygons, partial arcs, things like that. That. Um, you know, the mandalas are currently based on polygons where we put circles at the center points of the vertices. We can do all kinds of things with that. You can use circles of different size. You could use bigger or smaller radiuses than the base radius. You could use different shapes altogether, so we could draw polygons. I forgot to mention this here, and I just remembered that idea is sort of uses a mathematics thing called recursion. And so you can get very beautiful figures when you recursively call a function. So the idea here is I call the mandala and then I draw a mandala at each of the center points for where I would normally have a circle. And I can do that recursively. I can do that to any number of levels. And so I didn't give you any recursive code here, but it'd be kind of cool. Just some other figures that kind of support the idea of this being a greeting card. So balloons for birthdays and graduations would be good. Ribbons and bows, presents like, you know, wrapped gift presents like we have at birthday and Christmas time. A more mathematical idea, I mentioned how these methods tend to create like what's known as a path. And so you can chain all these figures together. So you could randomly change a number of points together and randomize which figure drawing method was called. So, you know, I'd have segments that were joined to different kinds of curves that might be joined with arcs and things like that. So again, I didn't really show you any of that kind of drawing, but it's definitely possible. So you can, you know, draw like a smooth curve to form things like automobiles, starships, jets, any kind of object you can think of. And then the other idea I had was more symbols. And some of these can work with the idea of the greeting card. So having hands, thumbs up, peace sign. You could have some rude signs if you wanted. We can also have things like bells, hats. So, you know, the sky's the limit. You can think of things. You can play around with the code and generate a method. And then when you put it into the code framework that I've created, it'll just generate multiple instances of those and randomize them. And, you know, if you understand the code, you can see how you can do that. I think I mentioned this as we were working. About halfway through, as I started doing the faces, I realized it was more interesting to rotate the faces randomly as I generated them. And so then I made a series of figures that did that. And the problem is I hard coded that in, so you can't turn that off. So another option, which would probably change the architecture a little bit of the app, would be to add a checkbox for rotations, just like the one we have currently for fade, that would basically turn the rotation on or off. So for instance, if I wanted a kind of sea of smiling faces and none of them were rotated, I could do that. Or I could go ahead and turn the rotation on and it would be like it is now, where all the smiley faces would be rotated as they were drawn. So that's just a slight change, but again, that gives the user more options. I used a quadratic curve to make the heart, and it kind of gives you these sort of pointed lobes. So I think we could do better than that, and probably if we used a Bezier curve with an additional control point, we could get a heart that has fuller, more rounded, and less pointy lobes. And that would be an easy thing for you to play around with and implement. So that's a good idea, a very small change in existing code. Basically, that one place where we draw the heart, change it to a Bezier curve, and then figure out how to make the second control point. You'd have to change, of course, the position of the first control point. There's all kinds of stuff we can do with the faces. I'm thinking about actually the next time that I work with people and do an app like this, maybe to make an entire face generator where that's all it would do. And we can have different kinds of variations for mouths, eyes, noses, expressions, head and facial hair. We could even draw further and draw simple figures. One thing that I just remembered, I forgot to put in this presentation. I'm really fond of this artist named Keith Haring, who in the 70s, he was one of the first people that was kind of like a subway graffiti artist. And he draws a particular kind of style that looks like a doodle, where he has these sort of humanoid figures and often these figures are in groups. And Keith was quite the humanitarian. He was interested in social justice and things like that. And so he has these very expressive paintings that use these. They're not stick figures. They're more, outline type figures, sort of like chalk outlines, although that's kind of the wrong idea. And so one thing I'd like to do at some point is make a generator that generates figures like that. So there's all kinds of things you can do. And again, I'm just trying to kind of prime the pump and stimulate you to get some ideas. A bigger idea would be to create a phone app, either for Android or some other platform, the iOS. Now, the interesting thing here is that our HTML5 app should run in the browser on most phones. And there's a way that we can basically compile it into what's known as a hybrid app. And so it'll take the HTML, the CSS, and the JS that we've used and actually make a native binary. So it would be an Android APK format that runs on an Android, or the iOS format that runs on the Apple phone. And then there's also another series of formats for the Windows, the Phone 7 and Phone 8. So once you do that, you could even go further and use this hybrid technology to actually access the phone file system and some other features. So we could basically, have it let us save things onto the phone and do that sort of thing. And that leads us to an even further one, which would be to integrate our app into social media. And so we could integrate it into Facebook or Twitter or those other social media sites like Google Plus. And then the user could send greeting cards directly from the app to people who are on their friends list, or they could post them on their timeline, or for instance, with Twitter, they could tweet them. So these are all just really grandiose ideas, but really quite doable. and especially with the code basis that we already have. So it's not like we'd have to completely re-engineer everything to make it work. You can create Facebook apps with HTML5 and JS, and you just use some specific JavaScript libraries for Facebook. Similarly with Twitter, and again, I talked about the hybrid technology for the phones. So I just want to thank you. I really enjoyed putting this stuff together. I'm sure that one thing that came out of this is how much I enjoy playing with this technology and enjoy it. When I first started to learn to program, one of the things that I played with was just creating simple graphics on old 8-bit computers. That's how old I am, the old Commodore 64 and the Apple II. And so it's really just an honor for me to be able to share my passion for this with other people through my teaching. I hope that you'll enjoy this and kind of catch the bug, so to speak, and maybe consider a career in a STEM field. And I just want to remind you, only use your magic for good and help others in your life. And once again, if you end up making a bunch of cash with any of this, I'd appreciate if you'd share it with me. That's the fair thing to do. And you know how they say, pay it forward. So thanks again. I'm looking forward to meeting you all this week, and I hope you enjoyed this. I definitely would like to try and do it again. So take care. Bye bye.